Welcome back. Last talk before lunch here, track 1, Forward Cloud Tech Day 1. This is inside Microsoft's battle against cloud-enabled deepfake threats. Quick announcements before we get started. Cell phones off. Questions after the talk on Slack or raise your hand and I'll bring the mic to you. And we have swag for good questions today. It's exciting. Lunch is going to be immediately after this talk outside. Feel free to pick up lunch and bring it back in, bring it to a Birds of a Feather room. And lastly, if you ordered a t-shirt, please go to the registration desk and pick it up. There's no reason for us to bring them home. With that, please welcome Bruce and Stefano. Cheers.
Thank you. So hi everyone, I'm Stefano, here is Bruce, and today we're going to talk about deepfake and how attackers are using Cloud API for deepfake. In this case, we're also going through some of the work done by Microsoft on their lawsuit that they did in December, but we'll talk about that a bit later. So let's start introducing the main content. So let's start introducing what deepfakes are. It's pretty famous already, but just for the sake of argument. Deepfakes are synthetic media, which usually are videos, images, or audio created by AI using deepfake learning techniques to manipulate or generate new contents in order to pretend to be real. So that's the main part, like the pretending to be real. In the slide, we just added 3 main cases that happened very recently. And very different from each other. So one is related to Mr. Deepfake website, which was a website that got closed, which were pretty interesting because you could ask for on-demand content and on-demand deepfake content on whatever person you wanted. So very convenient, very easy to get, and of course you will get the deepfake content as soon as we pay, and that's it. So very easy. Of course, it got closed with a pretty big fine for the person who created that. The other example that we posted here is a British engineering company, Europe, which got tricked into sending to attackers $25 million. How it worked was mainly deepfake videos was used in a call in order to simulate senior management approves for to sending money to the attackers. In this case, were different payments shipped to them, like 15, and then attackers were able to exfiltrate $25 million, which is a pretty good amount. The last one is related to elections, which we know being a very hot topic. In this case, it's happening in Slovakia, where a video came out on a top candidate for the election and claiming to have a rigged election for his advantages, of course. So this could be very disruptive, of course, for his campaign, but for the overall election, I guess. So. Those are just 3 examples in order to start just saying that, of course, the deepfake issue is real, is something that we have seen before, and first of all, we need to kind of start dealing with them and start to understanding how to deal with them. Now, let me introduce LLMjacking. Even in this case, it's something that has been there for a while. We spent some time, around 2 years, with LLMjacking in our research. We were the first publishing something on LLMjacking. During our research through these 2 years, we saw deepfake being one of the main goals for attackers. It's not the only one. We saw attackers also playing with content for role-playing websites, for instance. So deepfake, of course, is not the only one, but it's definitely one of the main things that attackers and threat actors want to do once they have access to Cloud API. How LLMjacking works, first of all, attackers trying to get credentials, usually by exploiting vulnerable applications or just extracting secrets from repositories around that they can find and scrape credentials. Those credentials, usually cloud credentials, are then used in order to call APIs on cloud, in this case specifically for any AI service in cloud, which could be Bedrock or Azure OpenAI or Vertex AI. Of course, it depends on the cloud. The other interesting things is also LLMjacking is now a thing, so it's very kind of well known. Is also added into Mitre to resource hijacking, because of course who is paying the bills eventually is the account owner who's got compromised. And we also in the past created a Stratus model related to AWS Bedrock, which was one of the cloud API that attackers were calling. One of the interesting part of LLMjacking is definitely OAI reverse proxy, which later on will kind of connect with what Microsoft found and the lawsuit that Microsoft did. OAI proxy, reverse proxy is a proxy that is mainly used on LLMjacking. We saw this using very extensively during LLMjacking attacks. How it works is pretty easy. So threat actors set up instances of this OAI reverse proxy. They sell access to the proxy, so end user eventually connect to the reverse proxy and starts using whatever API they want to use or whatever AI model they want to use for their purposes. It's pretty handy since kind of all the cloud are already integrated into that, so the end user don't need to care about credentials. They are already all in it. They can just use it. That's it. That's the kind of on-demand service that the threat actors are selling. And as you can see, support all the kind of cloud API that could be. The other important stuff, the important thing is that reverse proxy let you choose a domain if you want to choose a domain, or you can also, automatically set up a Cloudflare domain, which we will see an example later, which of course we know being very, very handy for attackers because it's masquerading the real IP. And here is how kind of OAI reverse proxy kind of fit with what Microsoft did. In December 2024, Microsoft did a lawsuit to a group of people which wasn't discovered back in December. In February, though, we saw some of those names coming up, and here we reported some of them. One thing that you can easily see is how many of them are related to reverse proxy and OAI reverse proxy that we were talking before. Kind of leading to how also LLMjacking is kind of connected to all of this. We can find here who created the OAI reverse proxy, first of all, and what Microsoft put together is also people that put together or created other instances for this reverse proxy, or also added some features for this specific OAI proxy related to specific cloud providers. We can see something related to GCP or Azure for Drago as well. The other kind of interesting fact is the last one, fees, which is kind of related with OAI reverse proxy, but is the developer who created the D3EU, which is a tool that Bruce is going to talk a bit about that later, but is still connected with OAI reverse proxy. This is a screen that we posted in our blog in February, a little bit before Microsoft kind of disclosed the names that we saw before. In this case, we can see this is a screenshot related to an attack that we recorded on LLMjacking. And as you can see, Drago is the threat actor. And we also kind of posted the the location, which fits perfectly with what Microsoft also posted in their report and in their lawsuit. The other important and also the name and the email, which fit with what Microsoft said. The other important thing is also the Drago, in this case, the threat actor is also selling their tools to Patreon, which is a website where people are selling not just content but also scripts. And we saw that he's selling the script that he used for credential theft and all the and like extracting credentials and also validate them, especially for Cloud API. So that's it from my side. I'll let Bruce go a bit deeper into the 3U and all the rest.
All right, thank you. So as Stefano mentioned, one of the main tools that have been used during LLMjacking attacks involving deepfakes is DE3U, which is a Python program exposing a web user interface. And it basically allows people to generate images using the DALL-E3 model, which is the main one for generating images of OpenAI, using this web user interface. This proxy can be integrated with the OAI reverse proxy. You can authenticate by either providing an access key for OpenAI or an access key for the OAI reverse proxy. In this case, all the traffic will go through the OAI reverse proxy. The author made this tool publicly available at rentry.org URL, which now has been taken down, as well as the GitHub repository of this tool. And one important feature of this tool is that it exploits one feature of Azure, because whenever you run a prompt to generate an image, Azure has a system to revise your prompt and modify it by either enriching it, or if it contains some word that triggers some content filtering, it modifies it in order to make it safe, basically. So this tool has a jailbreaking option, which basically inserts the user input prompt inside a jailbreak prompt, which basically tells the LLM to not modify your prompt and send it without any changes to the DALL-E3 model. And another important feature is that this tool strips completely the metadata. In the case of Azure, one security measure against deepfakes is that Azure puts some metadata regarding the origin and the provenance of the image. So for example, if the image has been originated from, generated by an AI, this metadata will tell us that it has been generated by an AI, and everyone can easily verify it on the web. But by stripping out those metadata, which are called C2PA content credentials, this tool poses a risk, an additional risk to the deepfake scenarios. So now we have all the components of the attack, which starts from stolen keys, which can be stolen keys used directly by the end user with D3U, or as we saw, stolen keys of an OAI reverse proxy. And then the user just puts his prompt to D3U to generate a deepfake image, and those D3U will be then forward the request to the OAI proxy through the Cloudflare, and then you will call the OpenAI APIs to generate deepfakes. So why this works is because it's very simple for an end user. He just can buy access very easily to an AI reverse proxy instance and use D3U to generate harmful content and deepfake stuff at large scale. When analyzing security incidents in the cloud involving AI, one could ask what are the responsibilities of the cloud provider and what are the responsibilities of the customer, of course. And to answer this question, Microsoft provided its AI shared responsibility model, which groups three main areas of responsibilities, starting from the AI usage, which defines how the AI capabilities can be used, starting from training your staff and the user to use those capabilities in a safe way. Then everything that it's related to access management is, of course, a customer responsibility. So, for example, defining roles and permissions, defining the roles that will be used by users and apps accessing those capabilities. Of course, the data governance is one of the customer responsibilities because the data that goes in and out are controlled by the customer. Then the second area is the AI application, which basically defines everything concerning how you build an AI application using Azure OpenAI. So if you design it in a safe way, how it interacts with other AI applications, how it connects with AI plugins, and most of these things are a customer responsibility. Also, Microsoft by default provides, of course, some content safety systems, but users can even add some custom guardrails. Therefore, this area is a shared responsibility one. And the third one is the AI platform, which is related to anything related to the compute infrastructure, which of course is an Azure responsibility to make it safe, and everything that is related strictly to the model. So for example, model data tuning, how the data fits into the model, which is model dependent in the sense that if you build your own model, it's one of your responsibility, otherwise it's a Microsoft one. Microsoft implements several technical procedures to make its AI service safer, starting from content filtering, leveraging like classification models that run both on the user input and on the LLM response, of course. Then it implements some abuse detection, which is on a heuristic, which triggers alert based on the usage patterns of the customers. Then, as we saw, they implement some prompt transformation to make your prompt safer in case it contains some harmful content. Then some prompt shields against adversarial prompts like jailbreaking stuff. And then Azure also stores prompts for up to 30 days. And only in case of any flagged content on those prompts, there is the possibility of like human review, in the sense that Microsoft employees can, in a very secure way, control and further analysis these prompts. By default, Azure OpenAI authenticates with API keys, but this is not the most secure way, of course. So if you really want to use API keys, be sure to follow the classical best practices, which is rotating those and monitor for exposed credentials. But instead, Azure suggests to use role-based access and Microsoft Entra ID for your users and apps accessing OpenAI. Also, it's suggested to restrict your AI apps in private networks and allow only access by approved network subnets. You can leverage advanced guardrails, which apply to images too. So the content of the images is checked too. And then you finally surely have to implement some runtime detection. How to do that? By default, Azure doesn't provide logging of events that are related to the LLM usage. Therefore, to do that, you have to configure another service, which is Azure API Management, to wrap the Azure OpenAI. And by doing that, every API called by Azure OpenAI will be monitored. You can configure this and eventually send all the events to a streaming service like an event hub, which then can eventually send those events to third-party software like runtime detection software, which have detection rules for monitoring and respond to threats. To do that, you can just enable diagnostic settings on your API management instance. Then you have to import, of course, the Azure OpenAI service APIs. And then you can just forward the events and write, for example, some detection rules based on the APIs. So, for example, there is the image generations create API, which is the one used by DALL-E 3 to generate an image. So that's one of the API you can monitor. And of course, you can also use the key QL queries to further analyze prompt input and LLM response in your recent activity. And with that, I leave Stefano wrap it up.
Yeah, so after, as you said, though, this is kind of a team effort, right? So it's not just what the cloud provider can do. It's not just what we can do in order to secure ourselves. We also need some guidelines and some regulation set. And like Microsoft in this case also published a very extensive report on what also policymaker could do and should do in order to update laws and update the regulation in order to match the needs and make sure that we can, for example, make sure that all the content created by AI is labeled in a way that it can be proved the authenticity, for instance, right? So all the things that can be done by policymakers needs to be done in order to make it kind of safe for public to use it and avoid exactly what we saw before in the example that we saw before. So this is literally a team effort where all the part needs to do their kind of job, all the kind of effort in order to make it secure and usable in the future. So that's it from our side. We are here for questions if you have any. So thanks for attending.
Hey, questions from the room? All right, I'll start with one. It seems like you've found a couple places where there are these open services that can end up being subverted to create deepfakes using sort of other people's API keys. Has anyone sort of started cataloging those? Is there like a good place, the Shodan of OpenAI applications? Yep. Like, what does threat intelligence look like for you in the space at this point?
Regarding deepfakes, huh?
Well, I just like the tools to create deepfakes.
I'm not sure. I mean, you talk about how.
It was just I had not heard of like D3U or whatever. Is the like where did you find that? Like what helped you sort of find those kinds of tools?
So we observed we have been observing LLMjacking attacks in several environments, AWS, Azure as well, and we try to fingerprint the attacks, trying to figure out where they come from, which websites which website was exploiting those environments, because, for example, role-play content was used by a lot of websites for fake girlfriend stuff, and as well as deepfakes. We figure out by fingerprinting the logs, we managed to find a way to see what was possible website using those, and for example, the tool D3U was used because in the logs we saw the jailbreaking prompt and this allowed us to fingerprint it as it is. But it was just like a dynamic fingerprinting phase. I mean.
Any other questions? All right, I guess we'll head to lunch. Thank you so much.
Thank you.
Cheers.